In this video, we will show you how to auto-tune a phase advance angle. This auto-tuning can automatically tune an optimal phase advance angle according to the rotation speed. The auto-tuning also helps you reduce much time in tuning, more than by manual tuning. This time, to show you how to auto-tune the phase advance angle, we'll go through these procedures in order. Here's how to connect the devices to the demo board. Your PC and IC are already communicating. Now, let's start with connecting these devices. Before you start, check the connector positions on the demo board. Slide the knob 1 of switch 1 to the off side. With this setting, rotation pulse signals from the FG pin will be generated 3 times per 360 degrees electric angle. Slide the knob 2 to the on side. With this setting, the motor lock protection will be disabled. We don't use the knob 3 and knob 4. We'll check waveforms of U-phase Hall signal, U-phase output voltage, U-phase output current, and rotation pulse signal. Next, connect the devices. Be sure to connect the devices after turning off the AC power supply. Connect the motor wire to the connector J8. Connect the Hall IC wire to the connector J5. Connect the power supply wire to the connector J1. Connect the voltage probe to the HUP pin. Connect the voltage probe to the U-phase output voltage pin. Connect the current probe to the motor wire cable. And, connect the voltage probe to the FG pin. Let's move on to setting the GUI. First, set the number of magnetic pole pairs in the motor. Set the value of the shunt resistor for the demo board. You can set the values up to 2 decimal places. The values with 3 or more decimal places are rounded off. Select the direction of motor rotation. Select Auto. In the vertical axis box, set the maximum value of vertical axis of the graph. Feedback current is the current that flows through the shunt resistor. In the lead angle max box, set the maximum value of the phase advance angle. In the lead angle step box, set the step of the phase advance angle. In the RPM max box, set the maximum value of the motor rotation speed. In the RPM step box, set the step of the motor rotation speed. The finer the step, the more accurate the tuning. But the tuning time will be longer. The auto-tuning starts from a motor speed of 200 RPM by default. In our setting, the auto-tuning will go through these steps in order. That's all for preparation. Now, let's start auto-tuning. Turn on the AC power supply. Apply a voltage based on actual operating conditions. If something unexpected occurs while checking the motor operation, turn off the AC power supply. Click Run. At this point, the motor will not start rotating yet. Click Auto Tuning. Then, the motor starts rotating, and the tuning at a rotation speed of 200 RPM starts. The message in the red frame appears during the tuning. The motor speed box displays the motor rotation speed. The current feedback box displays the feedback current. The degree box displays the phase advance angle during the tuning. Each time the tuning of the steps we set is completed, the graph displays the phase advance angles tuned at the individual steps. When all the tuning steps at each rotation speed are completed, the GUI displays the smallest feedback current value from among those measured at each phase advance angle. You can see that the smallest feedback current flows when the phase advance angle is 15 degrees at a rotation speed of 200 rpm. Then, the tuning at a rotation speed of 400 rpm starts. We will now explain the motor speed, together with the operational waveforms. During the tuning, the rotation speed displayed in motor speed can go up and down from the specified value. For example, when the specified rotation speed is 400 rpm, the value appeared in motor speed will be 408 or 387 rpm. By comparing the operation waveforms at each rotation speed, you can see that the VU periods are different. Various parameters are changed during the tuning, which means the amount of IU changes. The VU period depends on the amount of IU. The larger the IU, the shorter the VU period. As a result, the rotation speed increases. The smaller the IU, the longer the VU period. As a result, the rotation speed decreases. The tunings at rotation speeds from 600 to 800 rpm will continue. The message disappears after the tunings at all the rotation speeds are completed. The graph displays the approximate line based on the auto-tuning result. The approximate formula is displayed in the red frame. Click Stop. Be sure to click Stop. In fact, the motor automatically stops when the tuning completes, but this is required for your safety. Turn off the AC power supply. Now, that's all for the auto-tuning. As we have demonstrated here, the auto-tuning automatically tunes the optimal phase advance angle according to the rotation speed. To check the auto-tuning result again, or to tune the phase advance angle in finer steps, go on to the semi-auto tuning. Thank you for watching. We hope this video will help you.